Hi everyone. Today we have the privilege of hearing from Anima Acharya, a data engineering at Bingo Industries with over 4 years of experience building and optimizing data pipelines. Anima is a proud advocate for women in tech, serving as a Women Techmakers Ambassador, and she is always eager to share her knowledge. In her role at Bingo Industries, she focuses on creating efficient data solutions that help businesses make sense of their data. And today, she'll be guiding us through a fascinating talk on building modern data engineering pipelines with DBT and BigQuery. Let's give her a warm welcome.
Thank you, Ria. Hi, everyone. Thank you so much for being here, for giving your precious Saturday for GDZ DevFest today. I hope you are enjoying the event as much as I am. So today, for the next 30 minutes, we are going to talk about how we can build a modern data engineering pipeline using DBT and BigQuery. But before that, let me give you a quick introduction of myself. So I'm Anima Acharya. I'm a data engineer at Bingo Industries. So Bingo Industries is basically an Australia-based recycling and waste management company. I'm also a Women Techmakers Ambassador, which is a Google-led community that supports and empowers women in tech. If you would like to follow me through the slides, you can scan the QR right there and you can follow through the slides as well as you can connect with me over the LinkedIn. Ready? All right, let's get started. Okay, so before we get into the thick of things, I would love to know my attendees a little bit. So may I know how many of you or maybe any of you have built a data engineering pipeline, maybe in your work or as your pet project? Anyone? All right. Okay. Anyone have used BigQuery so far? DBT? All right. Okay, that's fine. So today we will start with the basics of what data engineering is. So even if you are new to the topic, feel free to raise your questions by the end of the session. We'll cover with the basics of what data engineering is, what ETL and ELT means, and how does that work. And we will dive a bit into BigQuery and DBT. I'm not sure why this is not. And I have a quick demo prepared for you all. We'll go through the demo, followed by our key takeaways, and we will wrap it up with a question and answer section. So let's get started. So what is data pipeline? Before getting into what data pipeline is, if we simply split the term data pipeline, let's split it into two parts, data and pipeline. So what is data? Right, so data, any kind of information is a data. We generate million terabytes of data every day through internet. So data could be useful, data could not be useful for any analytical purpose, but everyone is generating huge amount of data every day. So with that, what is pipeline? Now we know what data is, so what is pipeline? So whenever I hear the term pipeline, the first thing that comes into my mind is this one, the water supply pipeline, right? Something that we have heard and we have seen since our childhood. So what happens here is the water from the source, water source, is taken to every household, which is the destination. Similarly, with the data pipeline, what happens is the data from the source is being processed to the destination. So taking a data from the source to the destination is basically a data pipeline, if we say that in a layman term. But in data engineering, we have few processes by using which we take a data from source to destination. So here you can see few steps which undergoes in a data pipelining process. So from a data source could be anything, maybe CSV file from Kaggle dataset if you are doing some paid projects, or maybe in company, some employee-related data, some data analytics from Facebook, Amazon, internet, anywhere. So from the data source, you collect the data, then you process that data using different processing tools, which we are going to cover in next slides. So we process the data, we store that data in some data warehousing, maybe some cloud service provider, AWS, Azure, anywhere. And then the end user will consume that data for maybe reporting needs, business decision making, or any other purposes, right? So by that, we can build a data pipeline where a data from source get transformed to destination, to a BigQuery, and the end users can use it. So let me just give you a simple example. So let's talk about Australian dream. Everyone, I think, buying a real estate is everyone's dream, right? So let's take an example of how we can build a data pipeline based on a real estate data. So let's suppose there is a real estate company. So the company can use the NSW property data to, like that NSW property data could be a source of data for a real estate company. So that from that data, they can use that data and process the data. So that is where the processing comes in. So after processing the data, they can store the data in some data warehouse, after which from that data, they can now identify which is the fastest growing suburb of Sydney. Based on that, the real estate agency can start investing on that suburb and start their business. So from a raw data, which the real estate company has collected from NSW website, now they have some insights from that. So now they can use that insights to grow their data. So that is one of the use cases. There could be different use cases similar to this one for the pipelining. So since we now, by far we talked about what data is, what data pipeline means, what is the steps for our data pipelining. Now let's talk a little about what ETL and ELT stands for and how does that work. So ETL basically stands for extract, transform, and load. So what extract means is the data that we collect from any data source. In the previous example, we talked about real estate where we talked about NSW property sites. So we extract the data from NSW property sites. That is what data extraction is. And then we transform the data because the raw data that is available might not be what the business requires for, or maybe might not what I want to achieve. So transform the data in a way that is suitable for the business, transforms and standardize it as per the business standard, and then load the data into the data warehouse. So now with that, we just completed ETL data pipeline. Similar to ETL, we also have a ELT data pipeline. Just the difference is in ELT, we extract the data, we load the data first, and then we transform the data. So in these are two of the techniques two of the methods that a company usually use to do data pipelining. Depends on what company wants to. Some company might follow ETL, some company might follow ELT. There are pros and cons in both of these, but these are the two steps that are generally involved while creating a data engineering pipeline. Now, let's dig a bit into BigQuery. All right, so the extraction could be anywhere. So BigQuery is where the L, which is the load, comes into. So BigQuery focuses on load of the databases in the ETL workflow. So some of you had raised hand before as well, and some of you have worked already with the BigQuery. So BigQuery is basically a serverless data warehouse which is provided by Google Cloud. So BigQuery can handle petabytes of data and query petabytes of data within a second. So it is really scalable and easy to maintain data warehouse that company use. Similar to that, we have DBT, which stands for Data Build Tools. So Data Build Tools focuses on the T of ELT. So it's where the transformation takes place. So any data that you load into the BigQuery, now you can transform those data on top of BigQuery and change it as per your need. So BigQuery is, there are two services provided by BigQuery, BigQuery Core and BigQuery Cloud. So BigQuery Core is free to use. It is open source for transforming raw data into analytics form. You can automate your data transformation using BigQuery and transform your data seamlessly. So in BigQuery, you can materialize data models as tables or views or maybe incremental tables. There are different ways of materializing the tables in DBT. So now we know that there are different tools available. BigQuery, DBT, could be some other tools as well, maybe Snowflake or Redshift, others as well. Now, since we are going to work on DBT and BigQuery, let's have a quick look on where in the data lifecycle DBT and BigQuery are used. So I have a simple workflow here where you can see that on the left-hand side, we have different data sources. So data sources could be Facebook, Spark, or any other sources, could be CSV file as well, right? So from those data sources, you can ingest data or say extract data using, there are other different extraction tools as well, or you can also write a Python script to extract data from a data source to your data warehouse. So here we are using ELT data pipelining method. So we extract the data from the data source. So this is where extraction takes place, and from there we load the data in our data warehouse. So our data warehouse here is a Google BigQuery. So we load the raw data in the BigQuery. So that raw data can now be transformed into the standard form using DBT. We have to write a model once, but once we write the model, it gets automated, and from the next time you don't have to do it again. So easy, right? And imagine working with hundreds of models, and you don't have to do it every day. So on top of BigQuery, you can transform your data using DBT, and that data can now be used by the data consumers. Could be data analysts, could be data scientists, or any other data stakeholders. So this is how the data lifecycle looks like using DBT and BigQuery. Next, we will walk through a quick demo, but before that, I'd like to mention that we are using Python for extraction process. I have a local CSV file, and I'm running a Python script to load CSV file into BigQuery. So I will be using BigQuery as my data warehouse, where I load my raw data and then later the transform data. We'll be using DBT as our transformation tool. And we will create a short and small dashboard in Looker Studio. So for this one, I have played a smart role here. What I have done is I have recorded a video already. So I'll go through the video, go through the each steps involved here. So now before going into how we do that, let's first see what we are doing here, and then I'll go into the technical part of it to show you how we are doing this. So here in the screen, you can see that we have a project created in BigQuery. So this is how the BigQuery looks like. So we have a project, we have created a different data sets here, real estate data sets, different folders for data sets, real estate data sets and real estate objects where we will be storing our datas. And we have a Python file here using which we will load our data. So using the command prompt, I will be running my code. So I'm using a Python file, upload_csv.py, which will upload the raw CSV file into BigQuery. And I have another command right there, DBT run and DBT test. So DBT run will run the DBT model that I have created, and DBT test is another feature of DBT which will test my data, test and validate my data. So what is happening here is we have successfully uploaded our CSV file into the BigQuery, and after that we are running DBT model. So we have two DBT models here. Let me pause you here. So here I'm using a command line to command prompt to run my scripts, but instead of that, in a business scenario, you might be using, or you can use other orchestration tools such as Airflow. There is one data flow provided by Google as well, or there is other called Daxter, so where you can create different DAX to pipeline your data. So instead of running command all at once, like Python upload_csv.py and DBT run and DBT test together, you can orchestrate this using other data orchestrations tools as well. So this is a simple project, so I have not prepared an orchestration tool, but I'd just like to mention that to you. So we have created two models right there. One is a table, the other one is a view, and now we are testing our data as well. We can see that our test has been successfully completed. So if I go back, I mentioned that we can materialize models as a tables or a view using DBT. So here we have we have built one model as a table and other model as a view. So my stage table is going to be a table, and for the reporting purpose, I'm using a view here. And I'm checking the column property ID from my stage table to be not null. So these are the functions of DBT. Now if I refresh my data warehouse, we can see the tables right here. So inside real estate data sets, there is a table called NSW property data, which is my raw data file. So in BigQuery, we can see the schemas of the table. We can see the data type. These are identified by BigQuery itself. We don't have to explicitly mention this one. We can also see the details of the tables in the BigQuery. We can also preview the data in BigQuery itself, and we can also write custom query to view our data. Similarly, inside real estate objects, we can see there are two files there. One is a table. So the first one is a table, and the second one is a view. You can see the difference in the symbol as well. So this is a stage table that I have did a little transformation. Since this is a Kaggle data, I didn't have to do much of a transformation, but I have changed the data types and all and loaded as a stage table, which I will be using for a reporting purpose in a reporting view called view RPT NSW property data. So we have just uploaded the data. We have just, basically we completed our data pipelining process. What we did, using Python script, we uploaded a CSV file into the BigQuery, and then we loaded the data into BigQuery, which is L, and then we transformed our data using DBT. So we just completed our ETL pipeline. Now we can use that data to create different models, so insights. So here we can see I have a simple dashboard built in Google Looker Studio. So here I have, from the data set, I have filtered 2023 data. So this is NSW property data of the year 2023. Here we can see the number of property purchased by suburb and the property type. And if we see the report here, we can see that Parramatta is the buzzing hub for real estates, which has, I think, which has 1,354 transactions in the year 2023. Impressive. And if we want to see a property type of Parramatta alone, we can see that more number of units are sold in Parramatta than houses, which makes sense, I think, because Parramatta being one of the biggest city of Sydney, there might not be lots of space for housing, right? So but we can see that 95.6% of units were sold in Parramatta, whereas only 4.4% of houses were sold in the year 2023 in Parramatta. And we can also see the average purchase price is 1.2 million. Pretty expensive. It's very hard to fulfill the Australian dream. Similarly, if we see the Blacktown data, the 977 transactions were done in the year 2023, and again it makes sense because we have more number of houses transacted in the year 2023 than units, which again makes sense, right? Because Blacktown being one of the outer suburb of Sydney, people buy house there more than units, which again makes sense. And the average purchase price in Blacktown is 1 million, still expensive. Compared to that, Liverpool, again, more units are sold. Still, Liverpool is another big city of Sydney. More number of units are being sold or purchased in Liverpool than in houses. And the purchase price is 1.4 million. All right, so with this simple dashboard as well, now we got insights of property state of NSW. So we knew which suburb has got a average price. We know the average purchase price of different suburbs. We know which is the fast growing suburb of Sydney. And with just one data set, imagine using hundreds and thousands of tables to prepare different insights and how insightful that could be. Now we just went through what we did. Now let's get into how we did that. Let's get into the technical part of data engineering. Now let me forward this. Now if we see here, as I mentioned before, we have upload_CSV, a Python script which will upload sorry. Sorry, just give me a sec. So we have a Python script which will upload a data from a local CSV file to BigQuery. Now, and So yep, we have our data CSV file right there, NSW property data, which gets uploaded to BigQuery, and we have let me skip that out. Now, since we have we have a data set there, the video is not working. So we can use to initialize big DBT and BigQuery. We can install a package using a pip called DBT core DBT BigQuery, which will set up a big DBT and BigQuery in your Python environment. And within the DBT, there are few configurations files which are very important for the project. One of them being dbtproject.yaml. So here you can see that we have a project name right there, real estate project, which is the project name that you can see on the left hand side as well. And we have a profile name right there. So profile is yet another configurations files in DBT from where DBT gets linked with the BigQuery. So using a profile file, DBT will identify from where it is about to get the data and from where it is going to load the data. So in the profile YAML file, we have set up the dataset name. We have passed a JSON file right there, which will link, the JSON file will be basically link DBT with the BigQuery. That is a file we download from our BigQuery database. And with that, we can connect DBT with our BigQuery, and we have here we have different paths to the folders that is on the left hand side. And models are another important part of DBT. So models are models are they are a SQL file. So models are written in SQL files, and that is where we transform our data basically. So we have Alright, so models are where we write our SQL queries, and that is from where our data gets transformed. So as I mentioned before as well, we can materialize models as a tables or views that we saw in our DBT as well. And these are the scripts, SQL scripts, which transforms the data. So here I have just transformed the data type of the data, and I have filtered out the property ID should be not null. And using the stage table, we are now writing a model, which is a view that will used for a reporting purpose. So from one table as well, we can write multiple tables and views and use that for our reporting purpose. So in DBT, as we all ran in the script as well, we have a feature called DBT test. So DBT test, there are different generic and custom tests in DBT. So a few of them generic tests provided by DBT are not null, like unique, and empty, whether the table is empty or not. So we have used not null to in the columns property ID. So while testing it, DBT will test whether the property ID from my stage table has any null values or not. So this is how we test the data in DBT. And we can also write our own test as per our requirements in DBT. So that is a quick demo. We just cover different aspects of, we just set up DBT and BigQuery. So all the folders that you saw in the BS code, those we don't have to write all those folder ourselves. We can just use DBT init command, similar to how we initialize GitHub repos. So DBT init will build all the folders and structures for you, and you can just write your models and test inside the folders. So we just set up a DBT and BigQuery, and then we linked DBT and BigQuery using profile.yaml file. By passing a JSON key there, we had a few SQL-based transformations using which we created a table, stage table, and a view. And we also had a test to check the not null of the table, of one of the column. And we also created a dashboard in Google Looker Studio using a DBT view. Now that was pretty much of it. So few takeaways from the session. So we talked about what data pipeline is. So in a layman term, data pipeline is simply a getting data from source to destination. Different process involved in between, but it is basically how we get a data from source to destination. Another one is BigQuery is the L in ELT. I think that is one of the important aspects that we can remember, and it is easy to remember as well. So it basically is the L where we use the loading part of ELT. DBT is the T, which is the transformation part of DBT, where we transform raw data into standard form. And using BigQuery and DBT, we were enabled to build a scalable and maintainable data pipeline. That is all. Thank you so much for listening to me. If you have any questions, the floor is open. You can scan the QR code right there if you'd like to connect me on LinkedIn, or maybe to get through the slides.
Thank you for your presentation. I had a question related to the number of threads you would allocate in BigQuery. I've used DBT with Snowflake, and I would set the number depending on the size of the warehouse I would use in Snowflake, but given in BigQuery, you don't really control the compute. Is there an optimum number that you would set for your threads?
For a number of what? You mean models?
Yeah, so threads would be the number of models that get built parallelly, but since you don't, is that not?
No. DBT does not have its own storage. As I mentioned, it runs on top of BigQuery. So there is not any limitations of how many numbers of models you can build. You can build as much as it's required and as much as you can store in your warehouse.
So you're saying that I could run set the thread to 1,000?
Yes, of course.
Okay, cool. Thank you.
Any other questions, guys? Any other questions? Amazing. Thank you, Anima, for an insightful session. Your clear explanation and demo made the concepts of DBT and BigQuery more accessible to us, especially for me.
Thank you so much.
Thank you.